So, how's everybody today? So, my name is John Spirko, and I'm just going to go ahead and get started with an agenda. We're going to go through some introductions to the speakers and also some introductions to how we're contributing to Velocity. And right after that, we're going to dive right into how Web API performance is different from regular user monitoring. And for those of you that were on the last call, we did a little bit of that already. We're just going to take a bit of a different approach on that. We'll talk about two-way performance SLAs between a consumer and a provider, or the publisher and the subscriber, depending on which world you come from. And then we'll talk a little bit at the end about analyzing API performance variation. So let's go ahead and get started. I'm going to go ahead and jump in now. Oh, just getting set up here a little bit on the. Okay, so let's talk about the speakers. And Andy wasn't able to join us today, but we have some good commentary from Andy that Rob will add in about the Dell environment, the Dell.com environment. Rob Dickinson is our operations architect. And we'll be showing you snippets of the product today that Rob is the architect for. It's called Foglight, just to add some color to some of the descriptions that we're going to give in those three use case areas that we talked about earlier. And my name's John Spirko. I'm the product manager. So I sit between people like Rob and Andy, and where Andy's on the front lines of DevOps and he's the production support guy. I collect requirements from him, and then I go back to Rob, and I take those requirements, and we work on them together, basically requirements on how to make Andy's job easier or how to help him take care of the performance inside of their production environment. Okay, so just to touch base on this a little bit, we're fairly new. Dell Software Group is fairly new to Velocity. We started in Santa Clara in June of 2013. And it's very different. We have a lot of people coming up to us still looking for hardware, but we're a specific division of Dell called the Dell Software Group. We had a vendor booth there last time. A lot of people thought we were taking care of laptops and servers, but we're really focused on software, and that's what these Velocity shows are about, is that side of the house. So we did also a panel, a presentation, and it was similar to this one where we had representatives from our development team on web performance with people from the Dell.com team, and we're able to go back and forth and kind of offer both perspectives to the O'Reilly audience we had there. In July, we had an O'Reilly webcast, and how to boost web performance using API monitoring. Today's more of a continuation of that API monitoring discussion we had. And then we have a one I'm really excited about in New York City. We have a Velocity conference in October, and one of the big things here is that we're going to have two new presenters. One is George Reese and one is Jill Rested. George Reese has written published several books for the Velocity, or through O'Reilly rather, and a lot of those are on cloud performance and also web API performance. And then he has another book a little bit older on MySQL. So he's going to be good to have and speak in New York City. So stop by and see us. So let's go ahead and get started. And we're going to start with how Web API monitoring is different from web user monitoring. And I'm going to hand it over to Rob just to go through some of the descriptions as he designed the product. Rob?
Thanks, John. Appreciate the opportunity to speak with you all today. If you wouldn't mind advancing to the next slide. There's a couple key differences in how API monitoring is different than real user monitoring. I expect from the audience we're already fairly familiar with real user monitoring and the techniques that are used to gauge real user monitoring performance. Part of the difference in monitoring API performance is that the technical interactions between a web page and an API call are different. One of those differences is in how many requests and responses are generated to the backend infrastructure. So if we're talking about a real end user experience that is being monitored, we are typically going to be talking about an initial request for a web page and one or more responses that go with that. So the page is going to contain the HTML code, of course. That HTML code is then going to reference style sheets and images and other page elements that the browser then loads through additional requests and additional responses. So we have this many requests, many response kind of pattern typically when we're talking about a real end user page request. Now, of course, if we're using a content delivery network such as Akamai, we have the opportunity to optimize those many requests down to a fewer number of requests. But this is the general pattern that we're talking about of many requests and many responses. We then need to take and group those requests and responses together in order to come up with a page load time that accurately reflects that user's experience. There's a number of ways we can do that. We can do that with browser instrumentation. We check what the response time is directly from the browser's point of view. Or we can make that measurement with a packet sniffer, where we look at the individual requests that are made, we correlate those requests into a page context, and then we can calculate the total response time that went with that original page request. So again, I'm assuming those techniques are fairly well understood by the audience that we have today. On the API side, though, the picture becomes a little different. Now, of course, there's variations to all this, but we're talking about the most common cases that we see from our customers. So in many cases, when we're talking about API monitoring, the technical interaction between the client and the server is simpler. We don't have many requests that are spawning many responses where the requests and the responses are then stitched together on the client side. It's simpler than that. The client makes an API call. The server responds to that API call in a synchronous fashion, and we can express the performance of that based on that one call. That's the typical pattern that we see. So that's one of the first differences that jumps right out is with web monitoring, you're talking about a number of different requests typically that have to be grouped together. With API monitoring, it's simpler, and you're talking about a single request and a single response that goes with it. Another key difference, and this is something that really gets to the health and the performance of the application, is the type of client that's used. So I'm referencing here the column on the right-hand side and the kind of pivots that we analyze. If we're talking about a real end user request, there's a number of different ways we can pivot that performance to try to get an understanding of the underlying factors involved. One of the most important ones that we use are location and browser. It's very, very common with our customers to see the application performance vary by geographic location and also to vary based on the type of client browser that's being used. You may have a lot of triage cases, for example, where the site performs adequately using one type of browser, but it doesn't work as well using another type of browser, and you have to figure out exactly where your gaps are and how to fix them. The other part of that is there are new browsers and new browser versions being released all the time, of course. So it's very important to make sure that your new versions work with the applications that you're already hosting. Those are all pretty common concerns around locations and browsers when we're talking about real user monitoring. When we're talking about API monitoring, however, the picture can be different depending on what kind of use case we're talking about. If we're talking about a mobile application, for example, that's making a SOAP or a REST call to backend infrastructure, then we very well may have the same kind of geographic variation in our data, but we wouldn't expect to see as much variation from the browser side because it's a native app. It's not a browser itself. Another use case there would be a B2B style integration where the agent that's making the web request is not a browser, but it's some other kind of program or automated service that is able to make HTTP calls and then process the responses. So if we're talking about SOAP or REST, we may be talking about back-end communications that are being done by an AJAX application or a mobile application, But in many cases that we see, these are not applications that are actually consumed by a browser at all. This is a case where a customer has a process that's running, an integration process, let's say, and that is receiving data from a third party or a partner, and the agent that is submitting that data and experience that performance is not a browser, but a program. So that's another key difference, is the kinds of variations that we're going to see in the real end user world. Device type is very important. Browser type is very important. ISP is very important. Depending on the API use case, you may find that those factors are dramatically reduced. You could only be talking about a few browsers or a few kinds of agents based on the partners or affiliates that you have. You also could be talking about a limited set of geographies because you know where those partners live and where their infrastructures reside. So when we're talking about modeling the API performance for SOAP requests and REST calls, we tend to get a lot deeper into the actual guts of the calls that are being made. What were the parameters that were being passed, for example? What was the SOAP operation that was being used? And those end up being the kinds of pivots that you want to use to be able to understand why performance was good in some cases but not good in other cases. So there's some big differences between real end user monitoring and API monitoring, and these are some pretty important examples along those lines. John, if you wouldn't mind stepping ahead to the next slide. This is an example of another key difference that we're talking when we talk about the real end user behavior as opposed to API monitoring. And it's what's happening on the back end and what is the performance time that's being measured. It can be more difficult to describe this. Sorry? 32. Oh. So when we're talking about an end user page request, the pattern is pretty simple. You're going to do a request to the server. The server generates some HTML, hands you back the original HTML for that page, as we said before, and then the browser is going to download the other page elements involved in that. So that is a synchronous operation with the website. I'm making a synchronous call to the web server. The web server is generating the HTML and then handing that HTML back to me in a synchronous fashion. And I know that the response time in that case is all of the latencies involved. It's going to be the latency on my network. It's going to be the latency on the back-end infrastructure. It's going to be the latency of the application server in actually building that page. And then the latencies in returning the data back to me. When we're talking about API performance, though, we can't necessarily make the same assumptions about what the response time actually means. So this is an example from ATG that just shows a few examples of how complicated the wiring can be on the back end when we're talking about even a simple web service. So when I'm creating a web service through ATG, I have a number of different ways I can hook that web interface into my back-end infrastructure. So I could make a synchronous call, similar to what I would do with an end-user request, where the processing of the API call, rather, involves generating a response and then delivering that response back to the client in a synchronous fashion. But if we're using that option shown there in the middle, where we have a JMS queue, now we have the possibility that this API is an asynchronous API. So in this case, the client is not necessarily waiting for the results. The client response time is going to be the amount of time to add that message to a message queue, but the response time doesn't reflect necessarily how long it took to process that message on the back end. That message could also be persisted and processed much later in time, the batch operation, let's say. So we have this ability to separate the response time then effectively between what we see on the client and what is experienced by the back-end infrastructure. That really isn't a pattern that we see very much. I mean, even with AJAX, right? We're talking about asynchronous operations from the perspective of the user, but the technical interaction is still synchronous. Your AJAX operation is still waiting for a response and then processing that response. So when we're talking about APIs, the client behavior can be quite different, even in the fundamental context of whether the call to the server is synchronous or asynchronous. And you have to know then, based on your context, what your response time really reflects. Is it the true response time to do all of the work similar to what you would have in a real user world, or are you talking about the response time just in terms of adding a message to a queue and then returning? So hopefully that gives you a little bit of context about when we're talking about API monitoring, why we really see this as a specialized discipline, and why we've built some specific tooling to help better understand those API use cases.
All right, thanks, Rob. With that, I'm going to go ahead and I'm going to just push this screen out here now, and we're going to go ahead and jump in. So what I'm going to show you now is a console that does web monitoring, and it also does API monitoring. So right now, just to give some color on what Rob was talking about, I have ATG all, and this is monitoring my end users. And there's 3.9 thousand requests that came in to the ATG commerce application. And then what we do is we break down those 3.9 thousand requests. There were 4 different browsers, there were 7 different content types, and there were 5 different locations. So these are all of the things that we're interested in when we're looking at a regular web page performance. Now, if we come up and we specifically want to do API monitoring, we might take some different perspectives and look at different things so that we really don't need to break down the browsers, like Rob mentioned before, or the content types, because they're all the same. So when we're looking at API performance, this is root performance, checkout performance, and JavaScript performance. I look at the same thing on most of my APIs. I'm going to look at the endpoints. So in this case, there's only one server that's serving back the endpoint. And I'll look at my different locations, my different client locations. So here the API root is getting hit by, it's being served up by one endpoint, and it's being served to 5 different locations. And then this really gives you, based on the properties of these are filtered based on the properties of the API requests. So you can use the things like the path or variables, parameters in the variables, or other information in there to really break these down and get the response time and performance information you need on these. So what I'm going to do is I'm just going to drill down real quick and show you the properties. I'm just going to find the related hits here. And this is just our root. And what it would do is these group all the individual requests together. So now we have the response time of each of the different API calls. And we'll jump into that more when we do some of the advanced searching, where we actually go in and look at those API calls. So I can do that same thing like I did on the root. I can do it on JavaScript. And I'll do more of this when we talk about the two-way SLAs so that we can understand those better and do some more analysis. Okay, so let me go ahead and jump back into the slides. Okay, I have to get out of this one for... Sorry about that, a little transition problem here. All right, so now next we're going to talk about establishing two-way performance service level agreements. And what's interesting here is all the people that we see, all the customers that we have that use our API monitoring, what they're really interested in are these two-way SLAs. So they have a customer that's using their API, and then they need to give them a way to understand it. So really what we look at here is perspectives. And we always use provider-consumer as the two perspectives, but some people like to call those pub-sub. I think mostly the IBM people, that's a common term there. So basically the provider is going to provide or publish the API, and the consumer is going to subscribe to that API. and basically consume those services. So they could be within a company, it could be B2B, even in the cases of like native mobile apps, it's even more of a B2C type of implementation. So when you look at with the service level agreement, I mean, there's a lot of these, and I'll hand it over to Rob to talk to some of the variation there. But the ones that we see used most are the ones where the consumers have to agree upon some rate. You know, I'll only hit that API 500 times in any given minute, or 500 times in any given 5-minute period, and they guarantee that rate won't be exceeded to the the consumer agrees it won't be exceeded in return for a certain speed of delivery. In addition to the speed of delivery, they want to make sure there's no errors coming back from those APIs because they're paying for that, right? So there's some type of financial exchange here. So really, it's a pretty straightforward interest. The consumer wants to know. If you're the consumer and you're doing monitoring, you want to know that the speed of delivery and the error rates are within your acceptable rates that you've defined in your service level agreement. If you're a provider, you want to make sure that the consumer isn't doing anything outside the boundaries of that published API, and also that they don't exceed the rate that they have agreed to, because you have to expect a certain rate coming in as the provider. So let's go ahead, and I'm going to jump back, and I'm going to show you again. We're going to jump in a little bit and look at that in the product. Okay. So I'm back on the same screen again, and we're looking at our different APIs. And what I'm going to do here is I'm going to look at the JavaScript. So what I can do is I can click on my checkout by locations. So this is actually I'm going to do my JavaScript one. So my JavaScript one has one endpoint, and it has 5 locations. So what I'd be able to do here is analyze the SLA by location. So I can see if these are my consumers, I can see a specific consumer from Ontario and their relative performance by location. Or what I'd be able to do is jump in and analyze the JavaScript overall. So here's really the basic things that you want when you're reporting. So this is a two-way SLA. All the information is right on this page. So you have an end-to-end response time, and this is your average and your back-end response time. So this is what's behind the firewall inside your infrastructure. So if you're a provider, you really can't do much about this end-to-end if it's not inside of the back-end. So this really gives you a perspective on, is it spending time out on the wire or at the consumer side versus the back-end, which is all on the provider side. Now the service level attainment, this basically gives you a threshold that you agree upon with your consumer. So I'll give you sub 2-second performance on all of your API requests. And you'll guarantee not the end-to-end, but you'll have to guarantee the back-end performance. So this way you say all those requests come back in a certain amount of time. And then there's the other side, right? This is the volume, the number of requests coming in. So during this time period, which is the last 60 minutes, there's 2,170 hit requests coming in for the JavaScript API. So I can do this, like I said, this is overall in the JavaScript, or what you might want to do is do it by location or specific endpoints so that you can see if certain ones there are affecting your SLA. And this is the type of analysis you really want to do. So in an advanced find here, I also want the details. So a lot of ways, I mean, whether they're web logs you're looking at or something coming off the wire, you really want to be able to see what the details are of those requests that are breaking your SLA. So right now, if I go advanced find, and you can see I do have some end-to-end here, so I can look at my end-to-end violations. And basically what this will do is it'll show me all of my API calls that are exceeding that threshold during the last 60 minutes. Now this is where we get into just a few of the details. I won't spend too much time here. But this is the back-end time and the end-to-end time of each of the individual hits. Some of these are very fast because it's all on the demo network. But basically the hit end-to-end time is what I can group on. Now these are all the individual requests, so these are the JavaScript names that came in. if you're using a REST API or a SOAP API, these will be formed a bit differently. And then what you do is you can look at the details of those individuals. And like I said, you can get wherever you get this, from sniffers or from web logs. This is the type of information that we provide on these, so that you have the details of the performance of the individual requests if there are violations. And yeah, I know a lot of people do this. This is more of a web representation. We'll take a look in the next section after Rob goes through some of the details. We'll take a look at how we can look at the back end, like how that request turns into something else once you get into the back end of the system. So the other detail here, if I want to see the individual hits, I can click on these, and this will actually show me a preview of the hit detail. So this is actually the hit that came back. So one of the nice things about having some of the records in different forms is that you can actually look at the details and see what the server gave back, either on the wire or at the Java level, depending on where you're getting the information from. So what I'm hoping to do today is just kind of give you a little color about how we group things together, and then some of the different ways that you can go into an analysis or trigger your analysis. In this example, being an SLA. Okay, Rob, anything you want to add here on the product side or on the slides?
Yeah, I just want to say a few words about the SLA calculations themselves, because one of my favorite things about this product is we have a tremendous amount of detail. Obviously, as we just saw, we have all the detail about the request, all the detail about the response, including the request content, including the response content. Literally every piece of information that we can possibly gather. One of the things that I really love about the product is the flexibility that we have on top to consume that data. So when we're talking about SLAs, there's a number of different ways that a customer could choose to express that SLA in the real world, and the tool has to be able to adapt to allow the data to be expressed in that fashion. So the simple case that we're showing here is a simple SLA where the business has stated the business goal in terms of a single threshold, right? And this is a pretty common case. It's the case that we normally start with customers. So the business will say, it's very important that my home page load in 3 seconds or less, because I know the competition loads in about that quickly, and we want to be good relative to the competition. So the business states that 3-second goal. You can then calculate a simple SLA of how many fell under, how many fell over, and you can then express back to the business in an easy-to-understand way what the service level actually is. So that's a very simple case. The downside of that simple case is it tells you how well you're doing, but it doesn't tell you a lot about how you're failing, right? You know that you have those failures, but you don't really have great ways to categorize those failures in a more discrete fashion. So on the opposite end of the spectrum from a simple SLA would be a distribution metric, where we have a number of different buckets where we put the response time into those buckets. So you might have a bucket for 1 to 2 seconds or 1 to 3 seconds, because that's how long the business told you to take, ideally. Then you might have additional buckets to express how your errors are being distributed. So you might have a bucket that is 4 to 5 seconds. So they're a little slow, but not terribly slow. You might have you might have other buckets for additional time ranges beyond that. And your technical people are going to love that, because it gives you a lot more detail about how the app is actually failing. But those distribution buckets, obviously, it's much more complicated. You have to decide what the buckets actually are. And then it's more difficult to interpret the histogram that relates from that. So for a business user to come in and look at something that's based on distribution metrics or histograms, there's definitely a learning curve to be able to understand what it is that you're looking at. Then there's a technique in the middle, which I'm sure most of you have heard of, which is AppDex. So AppDex is just another kind of SLA scoring. In the AppDex case, the customer is going to, or the business is going to express a single threshold. So it's very similar to the way that you would state a traditional SLA threshold from the business point of view. So the business still has the same input. They say the home page should come up in 3 seconds. What AppDex does then is it gives you a standard way to break down your outliers and your performance problems. It also gives you some best practices about how to set your buckets, what values of thresholds are generally acceptable, and some really good recommendations on how to dial that in. So you get a lot of the reporting benefit of having distribution metrics, because AppDex itself is a 3-distribution scheme. But the AppDex relates to a single number score that is then easy to understand by the business. So I think this is really the critical part of SLA management, is being able to express your SLAs and track the data related to your SLAs in a way that's actually relevant to the business. One of the other things I like about our product in particular is it's very, very flexible in terms of what can be scripted and what can be customized. So it's not uncommon for a customer to come to us and say, we've got our own way that we'd like to score traffic. For example, a financial institution that we've worked with, they have ways where they want to break their traffic down into what their premier customers see versus what their average customer sees. So a premier customer is a customer that's going to spend a lot more money. So we have the ability to do kind of custom scoring and custom scoring schemes along the lines of the application being monitored. So if you want to start with AppDex, but then mix that AppDex score with some other information and calculate a new score, those SLAs are generally very easy to express because we have all this data. So it's pretty cool.
All right, thanks, Rob. The next section we're going to go into, and we have some questions. I just want to remind everybody, if you have any questions, put them in there, and Rob and I will go through them, in the slides or in the product to go ahead and answer some of the questions you have. So go ahead and feel free to put those in. The last section we want to talk about is analyzing the performance and looking at the variation of the performance of your API. So this is the third big thing. So the first one is kind of understanding structurally how to represent your API performance in groups. The second one, that one is more about an SLA representation. How are the the 2 parties involved in the APIs interested? And now the third one we're going to go into is really looking at all the different things that can affect that performance. I'm going to turn it over to Rob, and Rob also has some commentary to add from Andy, who wasn't able to join us today. Rob?
Yeah, so this is something that it's a really common concern, and it has to do with the fact that our systems that we're trying to deliver here are complex. Right? I doubt that's a shock to anybody on the call today. I guess the key takeaway there is that we're talking about complexity that really no one would choose. So as an example, I'm sure everyone is aware of Dell.com. Dell.com it's a pretty big site. It's been around a long time. It's gone through a number of different changes and has evolved over the years. And when you're talking about this kind of real-world application being delivered, it immediately gets complicated, right? You've taken this thing out of the lab where it was all slim and trim, and the way your technical people designed it for high reuse and low footprint and all those kinds of things. We take these systems out into the real world, and now we have to live with these in production, and the complexity then begins to grow. Maybe we need a much higher volume system that we had initially, so we have to scale the system out to something that's more complex. Maybe we have a new kind of technology that we want to integrate alongside the technology we had before, so we get an additional silo in addition to what we had before. Maybe we have a new kind of affiliate program, or a new kind of third-party interface, or a new kind of third-party infrastructure that we're now dependent on. All of these things add up to infrastructures that are fairly complex, and another key point there is that reducing that complexity is extremely expensive, right? So in Dell's case, we make acquisitions all the time. So when we acquire a new business, for example, we have another set of business systems now that we have to figure out what to do with. And frequently, bringing all of those together into a single system and effectively removing all of your operational complexity is prohibitively expensive, right? Or it's not something that you can do right now, but something that you plan to do in the future. So there's a period of time where the business decides that you're going to live with that extra operational complexity. So for a site like Dell.com, over the 20-plus years that site's been running, when you're working with Dell.com, you are working with about 4,000 applications on the back end to provide different functions. Some of those are consumer functions. Some of those are enterprise functions. Some of those are support functions. Some of those are billing. Some of those are for fulfillment. The list goes on and on and on. Because we're not just talking about a website here. We're also talking about all the back-end manufacturing processes that are then linked to that website. So it's really not uncommon, even for a smaller scale customer, not necessarily a Dell, but the typical customer that we work with, even a customer that's been operating for only a few years, we can really see runaway complexity and the organization trying to come to grips with the complexity that's involved here. And so for the Dell.com case, we have about 4,000 applications, and about 2,000 of those are considered critical to the business to keep going. Now it's easy for somebody who's just a programmer to say, you would never do all that. I would never design my system that way, and nobody would. Nobody would intentionally design their system to be this complex. This complexity is something that creeps in over time. It creeps in with business initiatives, and the DevOps folks are left holding the bag, right? I mean, we do our best to support the technology. We do our best to enable the business to do these things. And then the complexity of those solutions are thrust upon us, and we have to make them perform adequately. So kind of the picture that we have here on this slide is fairly typical if you were to look at the interactions between different components on the network, and you're trying to get a total picture of what's happening on your network. It might look like this. And you say, well, I know there's a performance problem in there, but how am I going to find it? What our tool does is to help you understand the dependencies between these components. This is again, it's true of both end user and API monitoring. But with API monitoring, as we talked about before, the back end interactions there could be asynchronous or it could be more complex. So what we want to do is we want to be able to, for a particular transaction that's having problems, we want to be able to isolate out what was the path actually taken by that bad transaction through my infrastructure. It's likely a case that I have a lot of transactions that are performing adequately, but then I have some that aren't performing adequately. What I want to do is I want to take all the problems and I want to separate them from the good requests. So I'm going to take all the error requests, I'm going to separate those out into a separate bucket, and then I want to look at the dependency and the infrastructure of the bad requests related to the good requests. So what we typically would see then is we reduce that overall infrastructure picture to a dependency chain like this, for a single request or a group of requests where you know that specific chain of infrastructure is what's creating the problem. This is also where having all of the data about the request and the responses is so important, because what we frequently see is the difference between a good performing API call and a bad one is the actual data that's being passed in. Right? It's the application logic that's being triggered on the back end and some kind of bug being exposed through that. So just looking at infrastructure and whether your infrastructure is up or down is generally not enough. Just looking at normal performance across your infrastructure generally is also not enough either. You really want to be able to take those outliers, take those performance problems, and look at the infrastructure dependencies just for those and find out the common factors that are causing them.
All right, thanks a lot, Rob. So with that said, as Rob mentioned, one of the important things that we really see, and I'm going to go ahead and show you this in a minute, is really understanding all those pieces that are going to affect your performance as you go through. So what we're going to do is I'll take a quick look and just to recap here. So basically, we have a group of APIs into these different buckets, these different 3 buckets. There's JavaScript, checkout, and root. And then what we're doing is we're analyzing those on a couple different properties and giving you relative SLAs across those properties. And then there's basically some analytic capabilities that you would typically do as one of these users. So for example, if I drill down on the API's root, I say find related hits, or actually advanced find. Let me just go look at my back-end violators right now. And then what I can do is, based on all of these trace results, I can look at individual results. I could do a pivot, which would basically give me analytics. And this is usually what you walk through, whether it's a spreadsheet you're doing it on, you're doing it through some web logs, through a log analyzer. But these are the typical things people are looking at with their APIs. Another pivot you can do is to look at geographically the distribution of your hits around the world, or you can look at your hits, your errors around the world and see where they're all coming from. Actually, I don't have any errors in this traffic right now. Okay, but regionally, it basically would give you the volumes of those different things, so just the raw hit count. Now, the other part, besides all the analytics, right, where the things are coming from, what type of content they are, looking at specific requests, which sometimes you have to do, right, to get to the root cause. Are they sending me something bad from the provider side? Is the server giving me something bad back? So maybe you do have those outliers you have to analyze. But the other thing you really need to understand is where is this thing going once it hits my infrastructure, like Rob was just talking about. So if I click on this, the API root, instead of my SLA, which I'm looking at on my hits here, one of the things that I can look at instead is for response time breakdown. And this is really that other piece of the equation, right? So once it comes into my infrastructure, what are the different pieces that it's hitting? So it's coming in the front end. It's coming in through some web server. It's hitting our production Java server in this case. It's going through to some queues. So what I can do is actually explore the breakdowns or explore the errors, and I can see how it's navigating through those different components. And this is really what you need when you have an API that's in somewhere like Dell.com, right? You need to understand all these different pieces that it navigates. So here's a more detailed breakdown. I can click on individual requests. Now what we're doing is we're basically inside the firewall now. Instead of monitoring like we were, we're doing 100% monitoring by looking at all the web traffic. And I was showing you those requests before we're doing the analysis on. Now we're actually picking up the transaction in the back end. We're telling you which servers it's hitting. We're telling you if there's any virtualization involved. And then we're actually taking you through the different queues in this case. These are the ATG queues. So you can actually see the queues that the API call hit on the back end. And also, in this case, we don't have any. These are all queues. So it actually must be going to a queue to the database. But if there were databases represented, you would see the databases on the back end as well. So I'm just going to see the virtual environment here. So there's a couple different perspectives you can look at this. I don't have any different really. On the virtual environment, if there's certain shared components that maybe another app can be on the same virtual disks or virtual networks, you could actually see those effects on the dependencies, which is kind of going back to what Rob was talking about before, where you need to take this big complex mess and hundreds of servers and stop guessing about where that API call is going and have a more graphical picture like this. Now, some people do this with CMDBs. There's different ways you can do it, different tools for doing it. This is just one of the representations that we use it inside of Foglight. So that's really the two big perspectives, right? The perspective of the two-way SLA and then the perspective of the infrastructure, right? How is it navigating the infrastructure? So that's when I come back and I talk to Rob and I give him those requirements, really the big things are, what are these people in the field struggling with? And those are the two sides when it comes to API. Now, if we went into a regular end user demo and we talked about all end users coming in web pages, very different conversation that we would have. Similar monitoring, but a very different conversation. So just again to recap, the three big things we hope you took away from this today is, first, structurally understand your API calls and the properties of them and how they're unique. So a lot of that goes back if you're negotiating two-way SLAs, how to tie those back to the business. So find good ways to divide them up. I don't know if this would be the best way for you, like API root, JavaScript, and checkout. Maybe if the SLA was with somebody like somebody else in the business, I could have checkout, employee lookup. I could have validate location or validate address. So depending on what type of environment you're in, there will be different ways and different properties you use in those web requests to make this, this more logical division. So that's number one, is that structure. And then number two, consider both sides. So there's, in this app, the ATG app, for example, anybody who deploys ATG is going to have both sides. They're going to be the consumer of certain APIs, and they're going to be the provider of certain other APIs. So a good example of a consumer, they're going to consume some type of, usually a billing service. If they're sending their credit card checks out or PayPal, they're the consumer of that PayPal service. Now, at the same time, they want to put their catalog online so that you can sell it on Amazon. They're the provider of that catalog service to one of their partners. And then there's the same relationships like in a lot of companies that we're in, like Rob mentioned earlier, we're in a lot of financial institutions. And they don't like to write things twice. So what they'll do is they'll do this, validate customer last name, validate customer first name, and they'll share those services. So they'll basically publish those. And there's that same relationship there where there's a bunch of providers and a bunch of consumers. And you really should understand the side you're on, and then also make sure that you hold those consumers, if you are the provider, make sure you hold them to some of those other rate-based metrics, because that's going to make a big difference on the performance. Okay, and then the last piece is really just understanding the infrastructure. Right? There's going to be back-end infrastructure that's involved, and those are the three big things that can really elevate your visibility into an API. So that's basically it for our demo today. What I'm going to do is I'm going to go ahead here, and we're going to open it for questions and answers. And we do have a couple questions out there, and I'm going to start with one from David. Does Foglight have an API for automated monitoring? So the product I showed you today was Foglight, and we just used that to illustrate a few examples in those three big areas. The two collection technologies that we used, one was a network sniffer. So we saw all of the API calls as they came in over the network into the web server. And then what we did is we instrumented the backend going through the Java layers in this particular application. So there were agents that go on each of the each of the JVMs that are deployed in that environment. So on those two collection technologies, the network sniffer just kind of works, right? If you're sitting there on the network and you add another web server, or 2 web servers, the sniffer is just going to say, okay, that's ATG traffic, just pick that up too. So the sniffer kind of auto deploys for you because it's just, it's monitoring a pipe of traffic. So it really isn't impacted by a changing infrastructure. On the other side of that, the Java side, when you deploy new JVMs, usually in the model, the instrumentation can be built into that deployment script. So what we do is we do bytecode instrumentation, and that bytecode instrumentation communicates back to our server. So those 2 collection technologies can both be automated, depending on what you're doing, whether you're going to vMotion something or you're just bringing on new instances as needed. So that's really the automated monitoring piece. Rob, do you have something to add to that on automation?
No, I mean I think that covers it. It covers it pretty well. I mean the agents themselves, the automation that we usually talk about is the deployment of the agents or the sniffers. And if you're obviously if you're deploying a large number of those, you want automated help in doing that. But the kind of the beauty of this is whether you're talking about a sniffer or whether you're talking about Java or .NET instrumentation, instrumentation inside the application server, it typically doesn't matter. I mean, if you're using that as a real end user application, or if you're using that to serve an API, it's generally just traffic to us, just data to us. Like at that level, the semantics that we put on that data about making it more helpful for a real end user case, or making it more helpful for an API case, are kind of the views that we put on top of that data, if you will.
Yeah, that's definitely the big differentiator. We see a commoditization really of the collection of data, and really the battlefield right now for understanding and monitoring and doing these dependencies is how you use the data and make it better for analysis. That's what we really came at. The 2 big use cases we're seeing in the market today is to understand, the both sides on the API. The only thing that's a little bit different on the collection when you're doing real user monitoring versus API monitoring is that we would also use browser instrumentation. So there's basically a third data source once you move to API monitoring. And one of the things that's pretty unique about Foglight is, let's say you have browser instrumentation, you have the network sniffer, and then you have an instrumented application. We join all those traces together. So we're sucking traces from the browser, we're sucking traces from the network analyzer, and then we're also getting the traces from the JVMs or the CLRs, and they basically come together in one place. And that's really what we offer. That's is a bit different than others. There's a lot of manual methods for joining that today. I mean, everything from spreadsheets and log files, to really join it up and show it as it goes across the infrastructure. That's what we take a lot of pride in our product right now. All right, so hopefully that answers everything on the automation. So the automation on the agents is the only part you'd really have to worry about. The next question is from Jeff. Question for John: how does Foglight handle large numbers of locations, like thousands of iPhones, calling a REST API? That's a really good question. One of the things that we do is we do an IP lookup. So when iPhones are coming in from different locations, we have a third-party database, and we can translate that IP address into a geographical location. So that's 90 to 95% accurate. Basically, depending on the regions, it varies in accuracy. So now we have those locations, and like for a popular app, you can have 50,000 cities in a sample period. So it's really hard to look at all those cities. So what we let you do in Foglight specifically is you can pick out key either cities, regions, which are like states or provinces, or even countries. And you could say, store 5-minute aggregates for these countries or these regions or these cities. And those you keep a limited number. So maybe you like do New York, LA, Dallas, London, someplace in Germany, Australia, wherever your big locations are. And those are the ones we're really going to pivot and analyze on for the locations in the view that we have for the location pivots. But the next step is like if you go down and let's say you get a bunch of traces, like here's 1,000 bad requests over the last hour. I want to analyze this. So there when you click the pivot, we do a real-time pivot on the trace data. And that will look at all the cities. So it'll put all the cities on the map like I showed in the demo earlier. So that really doesn't have any effect by the number of locations or the number of cities because it's just analyzing it within that small data set. Okay, Rob, any more to add on that one?
No, not really. I mean, I think you covered the cases. We can handle the case where in advance there are certain locations that are very important to you, and you want to be able to look at those and set alarms on those on a long-term trending basis. But then when it comes to understanding outliers, as you said, each of those traces contains all of the details, including geographic information. So just because you only choose to monitor a few locations in terms of setting alarms doesn't limit you in understanding and getting visibility into how your site is actually being used. So we just in terms of our technical facilities, we have kind of different ways of dealing with that. If you're talking about a search result, we're just going to pivot on the trace details. Whereas you might optionally set up more of a reporting object for specific locations, but there's a whole range of possibilities there, and it just kind of depends on what you're actually trying to understand from your location point of view.
Okay, and Rob, just take 30 seconds because we're running out of time. This last question: is there any recommendation or specific thing you would do for Node.js? I know you know that.
Not specifically at this time. One of the really nice things about the network monitor in particular is that it's web server agnostic. We don't have like Node.js instrumentation itself that would plug into the Node.js server. Not at this time anyway. But being able to monitor that from the network point of view, you still get all of the relevant pieces of data from the API usage point of view. So all the cases that we went through here today, the difference is going to be how tightly you're able to tie that to your backend infrastructure. But in general, it doesn't matter what web technology is used. For example, if you use an Apache server as a front end to a Java application server, which is a common pattern, we can monitor just the web portion of that, or we can monitor just the back end portion of it, or put the whole thing together to get a complete picture.
Okay, thanks. Yeah, we're out of time here, so I'll just wrap it up with more information. We have a couple of white papers, and this is just the first of, or not the first, but about the fourth of many submissions. We really want to be a Velocity member. Rob is also on the W3C Standards Committee working on the browser instrumentation. So we're really doing everything we can to really inject ourselves and be a provider with over 100,000 employees at Dell to bring all our experts to the table and really make them part of this Velocity community. So thanks everybody for attending our demo today. And yes, I don't know if I need to hand it back or for closing remarks.
Yeah. Folks, with that, we're going to say a really big thank you to John and Rob today for presenting an outstanding webcast for us all and for sharing their knowledge and expertise. And the demo they showed, wow, that is just so valuable there. You can really see it all in motion and how it works. So thank you, gentlemen, for that. We'd also like to say a very big thank you to all of you that attended our event today and hope you've benefited from it. Also, a big thank you to Dell for sponsoring our event today, and to let you all know that when it comes to web performance optimization, there's one critical part that's often put on the back burner: web API performance. Most IT professionals focus on real user monitoring, including synthetics, log monitoring, and/or advanced browser instrumentation. Yet these methods aren't suited for monitoring web APIs such as REST and SOAP, especially as companies expand their web application partner channels and mobile applications. Today you learned why common web monitoring falls short of pinpointing API issues and discovered effective alternatives from the webcast with Dell Web Performance experts John Spirko and Rob Dickinson. Again, thank you, Dell. Folks, you can download a copy of today's slides from your resource widget. It is the green file folder in your widget tray. Good information there to keep with you. We have the recording ready of today's event within 48 hours, so please keep an eye on your emails. You will get notified when that is available. Again, thank you, gentlemen. Thank you, Dell. This will conclude our webcast today. Goodbye, everybody.